Hello, kids. I'm Chavi Bansal. Hope you guys know me. Actually, so many kids that I know, they have requested me to put the video of physics for grade 10. So I thought let's put some videos over it. So today I'm starting with a chapter name light and light reflection and refraction. Okay. Let me share my screen first. I hope you guys are able to see my screen. Okay. So we are starting with the chapter name light, reflection, and refraction. Okay. Now, before we dive into this, have you ever thought about like why do we see objects more clearly at the daytime than the night? Or why, when there is very dim light in the room, it becomes difficult to see the objects, right? Or you need a source of light while you are, traveling on an Activa or a car to see on the road. Why light is required? What light is doing to see the objects? Or exactly what is light? Have you ever thought of it? Let's study the basic concepts. Let's see what is light. So light is nothing. It is a form of energy that travels in a straight line and helps in seeing the objects. Okay. So what is light? It is a form of energy. It travels in a straight line. Now you will ask me, how does it travel in a straight line, or how do I know it travels in a straight line? Right? So have you ever seen the concept of shadow formation? You have seen, right? At night, when there is a source of light, you stand in front of it. At the backside of you, there is a small shadow formation, right? Now, if light would not have been traveling in the straight line, it will not form a shadow. Why? Because light would strike the object and then it will change its path and move ahead. So why the shadow formation is taking place? Because light is traveling in the straight line. Okay. So this straight line concept can be proved by shadow formation. Sorry. Shadow formation, right? Formation of shadow proves that the light travels in a straight line. Now, how does it help in seeing the object? That is what the whole chapter about. So before that, let's understand more about a light. What is light? Okay. So we understood it's a form of energy. It travels in a straight line and it helps in seeing the objects. And the proof for straight line is it forms the shadow. Okay. Now the next question arises. Is light a ray particle, a ray nature, or a wave nature? Ray nature or wave nature. What does this mean? Ray nature means it is formed of particles. Okay. And wave nature means it is an energy that is transferred by the particles present in the medium. Okay. So that is wave nature. So can you tell me, is the light ray nature or wave nature? Let's see. Actually, even scientists were also very confused. Some of the concepts of light that we are going to deal with are explained by the concept of ray nature, whereas some concepts were explained by the wave nature. Let's see it in detail. Okay. Particle nature or ray nature of light. So this concept was mostly supported by most of the scientists like Einstein, uh, there are other scientists also. Okay. So what does this mean? Light is made up of, light is made up of particles. Okay. And these particles are called as photons. So light is made up of a particle called as photons, which is traveling from one place to another. Okay. What are these photons? These are the energy packets. Means small energy packets. And their energy is also quantized. What is quantized? What is energy packets? What does that mean? See, I'll give you a very simple example. When you go to a market to buy banana or apple, what do you say? Bhaiya, give me 2 apples, or give me 5 apples, or give me a dozen of banana, right? Do you ever say, give me 1.5 bananas or 1.7 apples? No, right? That is not possible. Same way, the energy is quantized. Quantized means it has a fixed amount of energy. It can be either 1, 2, 3, but there is no such thing between 1.3, 1.4, 1.8. No. Okay. Just like our ladder. We step, right? We put our legs on ladder 1, 2, 3, 4. So that is fixed. There is no ladder which is 1.2, which is 1.7, right? Same way, the energy packets means these photons have quantized energy, means fixed amount of energy. Okay. And these photons on rest, their mass is equal to 0. Okay. But light has momentum. What is momentum? What is momentum? Momentum is equal to mass into velocity, right? But mass at rest is 0. But when photons are traveling from one place to another place, they have the momentum. Okay. So what is the particle of light? Particle of light is called as photons, which are energy packets, means they have a small packet. They are like a small packet, which has fixed amount of energy. Okay. What means one photon means X energy, 2 photons means 2X energy, 3 photons mean 3X energy, and their energy is quantized. Okay. And the mass of the photon at rest is 0. But when light travels from one place to another, the momentum is non-zero. But light has momentum, which is non-zero. Clear? Now, this particle nature of light can explain lot of concept. It can explain reflection, photoelectric effect, Crompton effect, refraction, all these. Okay. Now you might not know what is photoelectric effect, Crompton effect. Reflection and refraction we will deal. We'll try to also include these two concepts in this chapter. We'll try to do at least the introductory part of this these two concepts. Okay. But at the same time, there are other concepts like diffraction, interference. These are not explained by light nature of, sorry, this is not explained by particle nature of light. So when these concepts were explained, but some of the concepts which we can see, happening are not explained by this. This formed the basis of wave nature of light. So means because particle nature was not sufficient enough to explain all the effects that is caused by the light, that's why it formed the basis of wave nature of light. But this theory, this particle nature theory also formed the basis of quantum theory. What is quantum theory? Quantum theory is where the light is considered as a particle nature and the particles are called photons. Whatever we discussed about the, particle nature of light, everything comes under quantum theory. Okay. Now let's see what is wave nature of light. So according to the wave nature of light, the light travels in the form of a wave. And which wave? Electromagnetic wave. Light is an electromagnetic wave. What does electromagnetic wave means? Means the wave has both the components, the electrical component as well as the magnetic component present. Okay. And it does not require any medium to travel. Why? For example, the light can travel in vacuum also, where there is no medium present, no particles present in the medium. There also light can travel because it's an electromagnetic wave. Okay. Just like other EM waves, light also has a range of wavelength, frequency, and energy. Means what? What are these? What is a wave? First, tell me what is a wave. See, this is a wave. Okay. Where the particles, if the particles are present in a medium, they vibrate at the position. Okay. They vibrate at their position and transfer that energy to the next particle by colliding with them. Okay. This is what the wave where the material is present in the medium. So what happens? This is called as wavelength or lambda. This distance. Okay. Now each wave has their characteristic lambda. Lambda means wavelength. What is frequency? Frequency is number of times a wave passes a point in 1 second. Okay. How many times the wave has passed the same point? Means 1 time, 2 time, 3 time, 4 time, 5 time. Whatever the number is, how frequently the wave is passing through that point, one single point in 1 second is called as frequency. Okay. And each wave has a particular energy associated with its wavelength and its frequency. Okay. Now, for example, in for example, this is one wave. This is another wave. So till this point, how many times? Here, 1 time only. Here, 1, 2, 3, 4, 5, 6, 6 times. So the wave A has lesser frequency than wave B, right? It means it is traveling very, very fast. And very fast requires very much energy. Therefore, high frequency, sorry, high frequency means high energy. Okay. Now you can see this is the wavelength, lambda. Means lambda is what? Wavelength, which is the distance between when the wave comes back to its initial position, right? So here, this is the wavelength, lambda. So you can see high energy means less wavelength. So can I say frequency, which is denoted by nu, is directly proportional to the energy, and lambda, which is what wavelength, is inversely proportional to energy. Okay. This is what wave nature is. Just a brief about wave so that you have a clear idea about it. Okay. Now this wave nature, it was able to explain interference, diffraction, but this was also not complete. But not photoelectric effect. Okay. So it was not able to explain the photoelectric effect. It means it is able to explain some concepts, but not the other concepts. Whereas the particle nature explains the other concepts, but not these concepts. So what did de Broglie do? De Broglie told that light has dual nature. Means sometimes it behaves as a particle, sometimes it behaves as a wave. To explain all the concepts related to light, diffraction, interference, photoelectric effect, refraction, reflection, every concept which is associated with light can only be explained being light a dual nature, being light a having a dual nature. Means light has both ray nature and wave nature. Okay. And this only explains all the concepts associated with light. Is it clear? I hope it explains a bit about the ray nature and the wave nature of light. So what can we talk about light? What can we say about light? Light, it is an EM wave, right? That does not require any medium to travel, right? Because when it is behaving as a wave, it does not require it. Second, it has dual nature, means it can be a ray nature also, it can be a wave nature also. Speed of light in vacuum is equal to 3 into 10 raised to power 8 meter per second. This is important. Speed of light. Okay, this is in vacuum. The speed of light will change according to the medium, but this is the speed of light in vacuum where there is no medium present. Okay, next, intensity of light depends on number of photons. Means what? For example, there is a bright light, it will have more number of photons. There is a dim light, it will have less number of photons. So bright light will have more photons and dim light will have less photons. Okay. What else? Energy is quantized in the form of energy packets, right? These all we can say about light. This is what we can actually summarize about light, whatever we have studied so far. Okay. Now, what happens to a light if it falls to a surface of other medium? What do I mean? For example, this is medium 1. This is medium 2. For example, medium 1 is air, medium 2 is glass. Okay. Now, there is a ray of light coming like this. What will happen to this ray of light? There will be two things that is happening. One, other. Okay. What will happen? Some of the light will be reflected from the surface, whereas some of the light will pass into the other medium. Okay. So this is surface. This is incident light, incident ray. Incident ray is what? It's a ray. Incident ray is what? Incident ray is a light which comes. Okay. Now, this is reflected ray because it has bounced back into the same medium, and this is refracted ray. And this dotted line is normal. Okay. Now, what do I mean by ray? See, when there are multiple light particles traveling into the straight line, it forms a ray. And when there are multiple ray traveling into the same line, it forms a beam. Okay. What is a ray? Multiple light particles traveling in a straight line is called light ray. And what is light beam? Multiple rays traveling together forms the light beam. Okay. So now do you understand from these concepts what happens to the light? Light will come, it will strike to the surface. Some of the light will pass to the other medium and some of the light comes back to the same medium. The light that comes is called as incident ray. The light which comes back to the same medium is called as reflected ray, and the light that travels to the other medium is called as refracted ray. Okay, don't worry, we are going to deal with all this in bit more detail. Fine? Any doubt? And this reflected ray is the one which makes the object visible to the human eye. Okay, means the rays that are getting reflected from an object is only making the object to be visible. Now, this forms the basis of our next concept called as reflection. What is reflection? Now we have an idea of reflection. When a light strikes at the surface of another medium, some light bounces back to the same medium. This phenomena is called as reflection. It is called as reflection. Means getting reflected back to the same medium. Okay. Reflected rays are perceived by human eye. Means what? Human eye can only detect the reflected rays. Okay. So reflected rays helps in seeing the objects. Okay. Now, in case of reflection, if I'll draw the diagram, this is medium 1, this is medium 2. This is ray which is coming. This is ray after reflection. So, in case of reflection, there are 3 components. And one more thing, the surface should be polished. Okay. So, same medium by a polished surface. This is important. Okay. Now, there are 3 components. First is incident ray. What is incident ray? This is incident ray. The arrow shows that the light is coming towards the surface. Okay, this is surface. Reflected ray. This is reflected ray. Third is normal. What is normal? This is normal. What is normal, by the way? Normal is nothing. It's a perpendicular that is drawn to the surface. Why is it drawn? So that it is easier to calculate the angle I and angle R. Perpendicular drawn to the surface. Now, what is angle I? What is angle R? Angle I is called as angle of incidence. It is the angle formed by incident ray and normal. Whereas angle R is equal to angle of reflection. It is the angle formed by normal and reflected ray. Like for example here, this is angle R. Normal and reflected ray has formed this angle, and angle I is the angle formed by the incident ray and the normal. Okay. Now, what do I mean by the, reflected light helps in seeing the object? There is a very common example. For example, there is a tree here and then land, and there is some water here, and then you are standing, right? Now, what happens? You can see the tree directly, but you can see the reflection of the tree also into the water. Why? Because water is acting as a surface. Is a surface, the water surface acting as a surface where the light that is getting reflected here from the surface is also observed by the human, right? So you will see an image of inverted image of the tree. Inverted means upside down. Okay. This is because of the light getting reflected by the water surface and coming to the human eye. Okay. You have seen it many places, right? Now we are going to talk about laws of reflection. There are two laws of reflection, and after that, we'll be doing some questions based on these concepts that we have discussed so far. So first law is incident ray, reflected ray, and normal all should lie in same plane. What does this mean? What is a plane? Plane is a 2D structure. For example, x-axis, y-axis, x and y, whatever it forms, it's a plane. There is no involvement of the z-axis. Okay? Means wherever the light is getting reflected, it should get wherever the light is coming, incident, wherever the light is getting reflected, it should be in the same plane. It should not go to the third plane. Okay? Second is angle of incidence is equal to angle of reflection. Means angle I is equal to angle R. This is there. If there is a reflection, angle I will always be equal to angle R. These are the two laws of reflection. First is all the rays, incident and reflected ray, as well as normal, should lie in the same plane. For example, this is one plane. Okay. Now, incident light came here. This is one plane. Nothing is coming to the z-axis here. Okay. For example, this is one plane. The light has come here, reflected back, but nothing is happening in this z plane, right? So this is what the first law says. And second law says that angle I is equal to angle R. Is it clear? Any doubt? Can we do some questions? Let's do some questions. What is the, let me write down few questions. I'll give you some time, then we'll discuss. What is the angle of reflection if the light falling to a water surface is 60 degrees? So the second question is, what is the angle of incidence and reflection if light falls perpendicular to the surface? Okay. Next is mm, 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 okay. The laws of reflection hold good for a plane mirror only, B, concave mirror only, C, convex mirror only, and D, all mirrors irrespective of the shape. Okay, next question. What is the speed of light in vacuum? Okay. What are the characteristic property associated with wave nature of light? Okay. One last question. Due to which property of light sharp shadow of an object is obtained? Okay. So these are few questions that are based on what we have discussed just now. Okay. Very easy questions, very simple questions, and all of them we have discussed in the video. Okay. Just take 2 minutes and try to solve this, and then we'll start discussing. Okay. Okay, let's discuss the question. Let's see the first question. So the first question says, what is the angle of reflection if a light falling on a water surface is 60 degrees? Okay, so this is the surface of water. This is normal, right? Now light falling on the surface means incident ray. And which it is making what angle? It is making angle I, which is equal to 60 degrees. Right? Now, according to the laws of reflection, angle I is equal to angle R. Therefore, angle R is also equal to 60 degrees. Right? So, the light will be reflected back at the same angle, which is 60 degrees. Clear? Next question. Again, there is a surface normal. Now the incident ray falls perpendicular to the polished surface. Perpendicular means it is coming along the normal. This is the incident ray. Now, angle of incidence between, what is angle of incidence between normal and incident ray? But now they both are the same, means angle of incidence is equal to 0 degrees, right? Therefore, angle of reflection will also be equal to 0 degree. So whenever the light comes perpendicular to the surface, it reflects back in the same path. There is no cone formation. It will come straight, it will go back straight. Okay, so this is the next example where angle I is equal to angle R. So here angle of incidence will be 0 degrees and angle of reflection will also be 0 degree. Fine. Is it clear? Next question. The laws of reflection hold good for plane mirror only, concave mirror, convex mirror, or all mirrors. See, the law, why is it called as law? Because it is applicable to most of the stuff, right? So when the first law is applicable, it is applicable to all the mirrors, even the second law. So it does not matter what shape of the mirror is, but it is applicable to all the mirrors. So what is our correct answer? Our correct answer is option D. Okay. Now, next question. What is the speed of light in vacuum? We already discussed that the speed of light is 3 into 10 raised to power 8 meter per second. Right? Clear? Next question. What are the characteristic property associated with the wave nature of light? This is also we have done. What are the characteristics property? We did it in detail. It's wavelength and frequency. What is it? Wavelength and frequency. Clear? Energy is associated with both, right? But the characteristic property associated with the wave nature is these two, wavelength and frequency. Fine. Next question. Due to which property of light, sharp shadow of an object is obtained? This is the first thing we discussed in this video. The very first thing, that light travels in a straight line, right? The first thing that we discussed when we discussed what is light, this is the first thing we discussed, that light travels in a straight line, which is very, 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 very important concept. Okay. Is it clear? I hope we are clear with the questions. We are clear with the concepts that we are done with, right? This forms the basis of the chapter. In next video, we'll go in detail about the reflection of the light through the mirrors, through the, different types of mirrors. Clear? Okay, guys, then if you have any doubt, please post it in the comment section. If you want such more videos, please that also post in the comment section. And if the concepts are clear, please share the video with your friends. And don't forget to subscribe it also. Okay. Thank you so much.